Optimizing IaC testing, C pipeline with Terraform, LocalStack, and GitHub Actions. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: The challenge of evaluating infrastructure as code, IaC infrastructure as code, IaC, has revolutionized how we manage and provision infrastructure. However, evaluating and testing IaC changes can be challenging, especially when working with cloud services that incur costs for each deployment. Ensuring your infrastructure code is tested thoroughly before deployment is crucial for maintaining high availability and performance. LocalStack, a solution for local cloud emulation. LocalStack is an excellent tool that emulates AWS services on your local machine. It allows developers to test and debug their cloud applications without incurring costs or waiting for cloud resources to be provisioned. Integrating LocalStack into your C pipeline will enable you to create a seamless and cost-effective way to test your infrastructure code. Choosing a GitHub Actions runner for LocalStack. Choosing the proper runner is crucial when setting up a C pipeline with GitHub Actions. GitHub provides hosted runners that can be used out of the box, but for running LocalStack efficiently, consider self-hosted runners. Self-hosted runners offer more environmental control and can be optimized for specific workloads. Configuring Terraform for LocalStack integration. Terraform is a popular IaC tool that allows you to define and provision infrastructure using code. Integrating Terraform with LocalStack requires configuring the Terraform provider to use LocalStack endpoints instead of actual AWS endpoints. Using tflocal for automatic endpoint configuration. tflocal is a wrapper for Terraform that simplifies the configuration of Terraform providers to use LocalStack endpoints. Using tflocal, you can automatically configure Terraform to use the LocalStack emulated endpoints, making switching between local and cloud environments more accessible. Manual endpoint configuration in Terraform provider. Alternatively, you can manually configure the Terraform provider to use LocalStack endpoints. This involves specifying the endpoint URLs for each AWS service in your Terraform configuration files. Here is an example of how to configure the AWS provider for LocalStack. Provider AWS. Region equals US East 1. Access_key equals test. Secret_access_key equals test. S3_force_path_style equals true. Skip_credentials_validation equals true. Skip_metadata_API_check equals true. Endpoints. S3 equals http://localhost:4566. DynamoDB equals http://localhost:4566. Lambda equals http://localhost:4566. Creating a GitHub Actions workflow. You can create a GitHub Actions workflow to automate testing your Terraform configurations with LocalStack. This workflow will set up LocalStack, configure Terraform, and run the necessary commands to validate your infrastructure code. Environment configuration, installing dependencies. First, ensure that your GitHub Actions runner has all necessary dependencies installed. This includes Terraform, LocalStack, and other tools required for your environment. Executing Terraform commands with LocalStack. Next, configure your workflow to start LocalStack and execute Terraform commands against it. This involves initializing Terraform, applying the configuration, and performing necessary validations. Sample GitHub Actions workflow. Here's a sample GitHub Actions workflow for running Terraform with LocalStack. Name: C pipeline with Terraform and LocalStack. On: push. Branches. Main. Jobs. Build. Runs on Ubuntu latest. Steps. Name, checkout code. Uses, actions/checkout at v2. Name, setup LocalStack. Run, Docker Compose upd. Name, install Terraform. Run, sudo apt get install y Terraform. Name, initialize Terraform. Run, tflocal init. Name, apply Terraform configuration. Run, tflocal apply auto approve. Name, validate Terraform configuration. Run, tflocal validate. Enhancing your C pipeline. To enhance your C pipeline further, consider containerization or self-hosted runners for better performance and control. Additionally, integrating tools like tflint for linting and static code analysis can help catch issues early in development. Containerization or self-hosted runners for efficiency. Containerization can improve the consistency and efficiency of your C pipeline. By using Docker containers, you can ensure that your environment is identical across different runs. Self-hosted runners offer more control and can be optimized for specific workloads, providing better performance than GitHub-hosted runners. Expanding validation with tflint. Tflint is a Terraform linter that helps identify potential issues in your Terraform code. Integrating tflint into your C pipeline can catch syntax errors, misconfigurations, and best practice violations before they become problematic. Integrating static code analysis tools. Static code analysis tools can provide additional layers of validation and security checks for your infrastructure code. Tools like Checkov and TFSsec can be integrated into your C pipeline to ensure your Terraform code adheres to security best practices and compliance requirements. Conclusion. Building a C pipeline with Terraform, LocalStack, and GitHub Actions provides a powerful and cost-effective way to test and validate your infrastructure code. By leveraging local cloud emulation and automation, you can ensure that your IaC changes are thoroughly tested before deployment, reducing the risk of issues in production. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.